Welcome dear students. In this video I am going to explain force and pressure. So let us start first. What is force? Force is an external effort in the form of push or pull. To understand more about this force and pressure, we will first learn about two types of motion. Actually, motion can be classified in different types. Out of that, we will learn two types. The first one is known as translatory motion. When a force acts on a stationary rigid body which is free to move, the body starts moving in a straight path in the direction of applied force. Such type of motion is called translatory motion. For example, when we push a ball on the ground, the ball starts moving along a linear path. That motion is called the translatory motion or linear or rectilinear motion. Next type of motion we will talk, that is rotational motion. A motion is said to be rotatory if any body moves in a circular path around a fixed axis without changing its position. For example, motion of a top, spinning top. After knowing these two types of motion, we will learn about a topic known as torque or moment of force. So what is torque or moment of force? Another name for torque is moment of force. The turning effect of a force is called torque or moment of force. When we apply force on a body which is pivoted at a point, the body starts rotating. That turning effect of force is called the torque. It is also defined as the product of magnitude of force and the perpendicular distance of the line of action of force from the axis of rotation. That is, torque is equals to force into perpendicular distance from the axis of rotation. We can denote this torque as a Greek word tau. It is known as tau. Tau is equals to force into perpendicular distance. So this is the mathematical form of torque. If we will talk about its SI unit, that means SI unit of torque. So SI unit of torque is let us see, force is measured in Newton and distance is measured in meter. So Newton meter is the SI unit of torque. If we will talk about its CGS unit, so CGS unit of torque is, similarly we can write, force is measured in dyne, so dyne, and distance is measured in centimeter. So dyne centimeter is the CGS unit of torque. We can define 1 Newton meter. So what is 1 Newton meter? The torque acting on a body is said to be 1 Newton meter if a force of 1 Newton acts on the body at a perpendicular distance of 1 meter from the axis of rotation. So this is the 1 Newton meter torque. Similarly, we can define 1 dyne centimeter. The torque acting on a body is said to be 1 dyne centimeter if a force of 1 dyne acts on the body at a perpendicular distance of 1 centimeter from the axis of rotation. So these are the definitions of 1 Newton meter and 1 dyne centimeter. We can talk about certain examples in our daily life that involves torque, like to unscrew a nut fitted with a bolt tightly, we are using a wrench. The wrench with a longer hand is very helpful. We can unscrew the nut easily if the wrench is of longer hand. Why I am telling easily? Because if wrench will be longer, then the force applied will be smaller. As we know that torque is equals to force into displacement. So as we have seen the wrench, and if this wrench is having the longer handle, so what will happen to this? If handle will be longer, so perpendicular distance will be longer, and if force will be smaller, then also torque will be longer. That's why a longer hand wrench is helpful to unscrew a nut fitted tightly with bolt. Another example of torque, if I will say, this steering wheel of a car. The steering wheel of a car is rotating from its axis, from the center, and there is the axis, and this is the perpendicular distance. We are applying the force tangentially. We are applying two forces tangentially, so that it will be 90 degree, and the applied torque will be, and the applied force for a smaller applied force, torque will be more. That's why this steering wheel, in the steering wheel we apply force tangentially, so that the torque will be more and applied force will be smaller. If steering will be larger, then this R will be greater. So there also the application of torque. More example, if we will talk, the knobs of a door are always provided at its edge. Why so? Look at this. If the door is this one, so knobs are provided at one side, and these sides are the hinges, means fixed axis of the door. So if we are opening this door by holding at the one end, another edge, so what is happening? The perpendicular distance R increases and applied force is tangential, so that we can open or close the door easily. If the knobs are provided in the center, so perpendicular distance will be smaller, and the smaller distance we have to apply large force. That's why the knobs of the doors are provided at the open edge or the other side to the hinges, so that the perpendicular distance will be more, and we have to apply a smaller force to open or close the door. Now we will see the next point, that is thrust. The force acting normally on a surface is called thrust. As thrust is a force, so its SI unit is Newton. So SI unit of thrust is Newton. Now we can see about pressure. The thrust acting per unit area of a body is called pressure. That is, we can write it as pressure is equals to thrust by area, or P is equals to F by A. This is the mathematical form of pressure. Now let us see what is the SI unit of pressure. As pressure is equals to force by area, force is measured in Newton and area is measured in meter square. So the SI unit of pressure will be Newton by meter square, or we can write it as Newton per meter square, and Newton per meter square is also called Pascal. So Pascal is the SI unit of pressure. We can define 1 Pascal. So what is 1 Pascal? 1 Pascal is the pressure exerted on a surface area of 1 meter square by a thrust of 1 Newton. Pressure is a scalar quantity. Now we can see the various applications of pressure in our daily life. Before that, we can see, as pressure is directly proportional to force, so if force will be larger, pressure will be also greater, and pressure is inversely proportional to area. So for larger area, smaller will be the pressure, and for smaller area, pressure will be larger. That means small area, if we apply a force on a small area, the pressure experienced on that area will be more. For example, I am keeping this pen along with the cap on my hand and pressing it. So I am applying force as the area is broad, so pressure applied on my hand is less. If I will remove the cap, now area is smaller, and if I will apply force, then pressure will be more as the area is smaller. Many more examples, many more applications in our day-to-day life. First, we can easily cut fruits and vegetables with a sharp knife. The reason behind that, sharp knife having very less area, so it exerts a large pressure on the fruits and vegetables so that it can cut easily. On the other hand, if we want to cut the fruit or vegetable with a blunt knife, it is difficult, because for the blunt knife the area will be more and pressure exerted is less. Another example, the needles. As we see the needles, the tip of the needle is very sharp, so that the area is less and pressure will be more, and it can work easily. Another examples, the high-rise building. The foundations of high-rise building are made very wide, so that on the large area the whole weight will be distributed and the pressure exerted by the building on the ground will be less. Another examples we can talk about our school bags. Our school bags are provided with a broad strips. Broader the strip, larger will be the area. Large area, less will be the pressure, and we can easily carry the bag on our shoulders. Now, another example, The wooden or concrete sleepers are placed below the rail lines so that the area will be more and the weight of the rail along with the trail will be distributed on a large area, and it prevents the track to sinking in the ground. As the larger area, so pressure will be less on the ground. So these are some examples in our daily life. That is the example of application of pressure in our daily life. In next video, students, I will explain about atmospheric pressure and its application. Thank you, students. Thank you for watching.